This screencast will explore the science of dactyloscopy, or the classification of fingerprints. Fingerprints have been used throughout history to sign business contracts and identify people, but the scientific study of fingerprints really started in the 19th century in India with a gentleman named William Herschel. In 1877, Herschel introduced the idea of using fingerprints to identify prisoners, and as early as 1880, Henry Faulds published a paper suggesting that fingerprints could be used to identify criminals. To find out more about the history of fingerprinting, go to the U.S. Marshal Service website listed below. Beginning in 1896, a standardized system of recording fingerprints based on pattern was developed. Each fingerprint card, called a 10 card, was imprinted with all 10 fingerprints of a person and marked with individual characteristics. Today, fingerprints are stored and available through AFIS, or the Automated Fingerprint Identification System. AFIS uses digital imaging technology to obtain, store, and analyze fingerprint data. Originally used by the FBI, AFIS is currently used by multiple agencies, including the FBI, the CIA, and Interpol. Fingerprints form before birth and do not change throughout an individual's lifetime. No two individuals have identical fingerprints because fingerprints are not controlled by genetics. Even identical twins have different fingerprints. Fingerprints are an imprint made by ridge patterns on the tip of the finger. Fingerprints are composed of water, acids, lipids or fats, and vitamins. The water, which makes up about 98% of the fingerprint, quickly evaporates and leaves the dried salts and organic compounds behind. This is a cross-section of skin showing the anatomy of a fingerprint. The papillae, which separate the outer epidermal layer and the inner dermal layer, determines the specific friction ridges that make up your fingerprints. Sweat pores along the friction ridges release perspiration, which consists of water and organic compounds. The water evaporates, leaving behind these organic compounds, which are then collected as fingerprints. There are three basic types of fingerprints that can be left at a crime scene. Visible prints are left on a smooth surface when blood, ink, or some other liquid comes into contact with the hand and is then transferred to that surface. Plastic fingerprints are actually indentations left in some soft material such as clay, putty, or wax. Latent fingerprints are hidden prints that are caused by the transfer of oils and other body secretions onto a surface. They can be made visible by dusting with powders or making the fingerprints in some way more visible by using a chemical reaction. There are three basic fingerprint patterns. We're going to start by taking a look at a loop pattern. Loops have one or more friction ridges that enter from one side, curve around, and then exit on the same side it entered from. Loops can be further subdivided into ulnar loops, where the opening is towards the little finger, or radial loops, where the opening is towards the thumb. Here we also see that we can have loops or double loops. Take a close look at these images of the fingerprints and trace the pattern to see where the loop starts and ends on the same side of the finger. A second type of fingerprint is a whorl. Whorls are fingerprint patterns with at least two deltas and a core. They form circular or spiral patterns, kind of like tiny whirlpools. They can be subdivided into plain whorls, central pocket whorls, and accidental loops. Take a look at these three images. Notice that in each of them, there's a circular or spiral pattern in the center of the print. Deltas are the triangular area where the ridges radiate outwards in three directions. You can see in this image where it looks like a triangle forms, and this is where the delta is. The core is the point that's found in the middle of the whorl, on the spiral, or on the top of the innermost loop. These are present on all loop and whorl fingerprint patterns. The final fingerprint pattern is the arch pattern and is the least common and the simplest fingerprint pattern. All ridges enter on one side of the finger and exit on the opposite side of the finger. There are two subdivisions of arch patterns, plain arches and tented arches. In the plain arch, it's kind of like a very simple wave that starts on one side of the finger, arches up, and then arches back down to exit on the other side of the finger. In the tented arch pattern, there are two separate ridges that actually join in the middle, and they thrust upwards and form what looks like a pitched tent. Arches account for about 5% of all fingerprint patterns. Now it's your turn to try to analyze fingerprint patterns. Turn to pages 98 and 99 in your textbook. From the 20 impressions in figure 4.13 on page 99, match the ones that are made by the same finger. In some cases, one print may appear 2 or 3 times. Some will not match. Submit this assignment on Schoology or write it on paper and bring it to class.